he doesn't have too much experience doing some programming, and I require some of the things that I need to do either be done in either no. Some of them are in Python, some of them are in MATLAB, and some of them are more mundane, which is the ground truth thing. The ground truth means getting a video and getting data off the video manually. So let me give you a very brief nutshell, 10-minute type of description of what the project I'm working is about. That's the subject of my PhD, my dissertation. And you probably, guys, I don't know if you are aware of a program that UNM had, which is called AOLME, in which they teach middle schoolers some computer practices and things like that. So they tape those videos, and I'm going to share the screen up, and if you can let me share the screen and show you one of the videos.
Yeah, one sec. Let me see. I believe you can now.
Okay. Okay. The videos look something like this. Okay. My drive is.
Put a little time, that's all.
No, what happens is I have all this on an external drive that goes to sleep, and
Yeah.
sometimes refuses to. Oh, there it goes.
Do you know how to turn it off?
Yeah, it comes up like right here.
Because that's how you turn off the monitor. So if you push that button, you're not going to be able to see the movie.
So you can see there are several students getting the table, and they share or they work with this Raspberry Pi computer. So it's a very noisy environment. And believe it or not, this is one of the best videos because the ones for which I have ground truth are horrible, terrible, nasty. They put books on top of the microphone. As you see here, this is the microphone that is capturing that. There is a camera that is behind here capturing all that noise, because it's noise, mostly it's noise. So the idea is giving the recording taken by this microphone. What I'm working is in a method that uses the location of the speakers to determine who is talking at a particular time and what amount of time they've been talking. So what I do is I get a video, I look at the video how it is, I know that the microphone is located here or by any place that I can more or less infer where it is, and I make a model, a simulation of this acoustic environment around here. And once I have done that, I simulate microphones using microphones that were around here, and I simulate what those microphones should be picking up based on the information that I have from this one and my simulations. So after 2 years of working, I got decent results. Decent results in the sense that, for example, like to give you an idea, by the way, I have here behind me an audio lab as well, in which I'm trying to put all on the speakers on all the microphones that will be on the simulation. I know you can see it over there, and then I can see in real time what's happening. I have a data acquisition system in the back that is getting all the microphones simultaneously, and then I start measuring what is called the cross correlation between microphones. To make the story short, now it's more or less working. The result that I'm getting, for example, is if the ground truth, the manual ground truth, tells me that the speaker has been speaking for 4.97 seconds, my software says that it's 4.25, 6.63, 7, 8.94, 8.25, 4.83. Here I have a little difference, 6. So it's working. It is, and these are not, in those numbers are no simulation. Those are real things captured by one single microphone and then running through the process. So the two problems that I have are this, and I'm gonna show you something else here. This is a track that I use, for example, here on my lab. Okay. This is taken from a movie. This is a track from a movie, 2001: A Space Odyssey. You may have seen that, in which a computer starts talking and starts saying weird things and try to kill the astronauts. So I take a clip of that movie, and I separate it in two audio tracks, one for the computer and one for the astronaut. And I play it here in my back on my lap, and I get this bottom line here. This is what the single microphone picks up, actually the camera. Okay. One of the things that I have asked my other student is to come and tell me for how long somebody's talking. For example, if I play this audio here, let me select this one and let me play.
It's very faint.
Yeah, they're faint.
Yeah, I
Okay,
can
let me
hear
play
it.
this. Boy, that door volume. Well, anyway, this audio track has the noise removed. I remove the noise from the movie and I put it in a CD. Put it in a CD and I'm playing in the background. When I'm playing this through the speakers, I'm playing it into the background. So the point is to make this a little bit more concise. I need to know for how long each one of them have been talking. But humans have a little different perception of when somebody is talking and something is noise. Because if you see here, if you see in this, for example, in this track, and I'm going to make it a little bit bigger, this is just one set of speech, either from the computer or for the astronaut. But you see that here we have some sign of silence, and then it keeps on talking. So that can be considered by a program silence, but for a human it's not. So I would like to come to some type of criteria in which we can coordinate both things. So now let me tell you a little bit how I'm working this right now, and that's another thing that I need. Because I'm working with delays between microphones, with cross correlation between the simulated signals. I need to get a piece of sample, and then I need to cross correlate that with everything else. Making sense? So if the segments are too long, meaning that I take too much of a space between segments, then there is a risk of overlapping. If the segment that I take for analysis are too short, they may not contain enough information. So the solution for that right now is to get what is called a voice activity detector. I need one. The voice activity detector is something that is going to do all the time the same thing. It's going to cut when you speak and switch between the speakers. And there is such a thing exists, but I haven't been able to implement it here. Make sense so far? Questions? That's a piece
I
of
have a
code that I need.
question.
One. Huh?
Are you separating each kid voice from the video?
Yes. I get each one of the pictures here, I color in segments.
Okay.
The smallest segment that I've been able to work with right now is about 250 milliseconds. And that's another issue because manually I'm correlating those segments to my audio to see how many misclassifications I have. But when the segment starts getting too small, like a quarter of a second, even for us humans, it's very difficult to determine who the hell is in the track because we can't understand either. My computer can know because still the signal is there, but we cannot understand that. So I have to come up with some way to get those segments correlated to the audio. If I'm going to be doing segmenting. If I do voice activity detection, I can have segments with a lot of information from just one single speaker. The problem comes again when speakers start overlapping or one switches from one to another.
Mm.
Please stop me if what I'm saying doesn't make any sense to you.
So in summary, I can say your input is some video and you're trying to detect who is speaking at what time.
Correct. The input is a video, as you saw here. But actually, what I'm doing from the video is I'm taking the audio. I don't care about the video. I use the video for one, just to get the model. And I can show you how the model looks like for this particular example. And this particular example works extremely well. Let me see if I can get it. Okay. So you see here I simulated the size of the table, the size of the room, but not the whole room. Just something that is enclosed. Put my speakers and my microphones in place, and I simulate this room. I see how it works. By simulating the room means I calculate the room impulse response between these speakers here and each one of the microphones. That's my reference. What I do later, I get those numbers, and using the center microphone here, I deconvolve each one of them, not directly because the convolution doesn't work very well here, and then simulate each one of these guys here, each one of these microphones that do not exist in reality. And there's a program here that I have. This convoluted screen here does all the work. This is a wrapper written in LabVIEW that runs code in Python in the back, runs a code in MATLAB, and then run it to calculate all the cross correlation between the virtual microphones, and comes to a very simple classifier that makes it both and tell me which one is the most likely one.
Okay, I have a couple questions for you. Okay.
Yes. Mm-hmm.
Can you go to Liz sample 1,
Uh-huh.
kids?
Please.
Yeah, I I see in the bottom middle of the screen. Is that one of your microphones right there?
No, this is the real microphone that is in the video. You see? I don't have microphones here. I only have this recording.
Okay.
And I can run the program. I can show you how everything works. Each one of the 250 millisecond segment takes around 16 seconds to be deciphered. Right? That's something that I know what's happening because he's doing the models all over. There is no need to do that kind of stuff all the time. But I have it that way in case I do a change and I forgot to put it back in to work, and then I will be scratching my head why it's not working. So, but this is the only data. The only data that I have is the audio and a simulated acoustic of this video.
Okay.
So let me see if I can. Here I have the. Let me open a new. Here, no, open up. This is what I have. This is the audio that comes from that video. That's all I have.
So go ahead and click exit. Do you know how to turn it off?
Yeah, it's on the mic right here.
Mm-hmm. Because that's how you turn off the monitor.
That's all it is.
Yeah.
Okay, and then what do you do with that audio exactly? Because I'm not quite sure. You said that audio is the input, and then you said about the simulation. I'm not really understanding the correlation between that input and that simulation that you're talking about.
Yeah, the next step, let me just tell you more or less how the thing is doing. With this audio, the next step with that audio, the software that I have, is to get a sample of each of the locations of the speakers. So you come here, and for example, you get this.
Go ahead and click exit. Do you know how to turn it off?
I'm sorry?
So you have that audio and you have one microphone in the
Yes.
room that is listening, and you're simply trying to map the location of the speakers in reference to the microphone,
Correct.
and putting that into the simulation that you built with the room and the table and all that.
Correct. And then it runs on the simulation, and then I pick up the boss probably plays that when the simulation is running. I train the system. By train the system means that I get a sample of each one of the speakers, because I need a sample of each one of the positions, and a sample of the noise, because I need to know the acoustic of the room. With those things, I put it into my model. I train the model and get that thing. That's it. That's all I need. The model get training in around 5 minutes. That's it. No more training needed.
So we build an AI, and then or you have the model already, and then you give it a sample, and you give it a sample of each speaker's voice and location and stuff, and each type of noise, and then the model hopefully will be able to predict the location of the speaker. And in the
Correct.
future, once you give it any sort of input, it will just be able to detect where the speaker is speaking from, the location of it.
Basically, that's the way. Yes, I
Okay.
just get one sample for each speaker and one sample of noise. That's all I need.
Okay.
Okay, and I put sample 1, sample 2, sample 3, and I dedicate one sample to noise. That's sample 4, because my models are now for 4. You can put as many as you want, and then you can, even if you have, for example, 2 speakers, you can have models with 5, 6, 7 microphones, in which you will increase your accuracy of your model because you will have more data to deal with, more microphones. Then I go and I segment this audio in chunks of, let's say, 0.5 seconds or 500 milliseconds or 250 milliseconds. If you have a speech that is very well defined, like this example that I have here, in which just one speaker talks at a time, your segment can be very long. And the longer they are, the better, because they contain more information. So you're going to be able to make the prediction much better than if they are very small. When you have crazy videos like the one that I showed you with Liz, your segments need to be very small because otherwise you're going to be overlapping. But that's because I'm not using a voice activity detector. If I have a voice activity detector, I may be able to switch between speakers, and the segments will be longer, and the probabilities of getting right will increase. Make sense? And that's one of my needs, a voice activity detector for that type of environment, which is challenging.
Voice activity detector, you mean, is a software that just simply detects when there is a pause or when there is the end of the conversation in order to split the segments for you?
Yes, when there is a speech, and there is MATLAB code that do such a thing, but it doesn't work very well. It's kind of bad. So I need something that is more tailored to this kind of environment.
And would that be MATLAB or would that be Python?
That could be MATLAB, because again, my program is running MATLAB behind. It could be MATLAB. It could be anything. I mean, again, the LabVIEW is just a wrapper. It calls the routine in Python and runs the Python, and then it calls MATLAB and runs MATLAB, and the only thing that is doing is showing me the GUI and the simple calculations of arrays and things like that are very easy to do in LabVIEW. For example, this is very easy audio because it's very well defined.
Birch canoe slid on the smooth line.
Silence.
Blue sheet with a dark blue background.
The birch canoe slid on the smooth planks.
It's easy to tell the depth of the well.
This is very easy. And this, in the case of audio like this, the segments again can be the whole thing. If they are the whole thing, it barely fails. It knows who is there. Because there is plenty of information to calculate the cross correlation between the virtual microphones and come up with an answer. Make sense so far?
Yeah.
Yeah, it's I mean, I've been working with this for 3 years, so I mean, having something very short in 10 minutes is kind of complex. Okay.
This,
So
this software is called Audacity, right?
that's Audacity, yes.
Okay.
Yes, I use Audacity to cut the segments and to get samples and things like that.
And you have your Python script in a Jupyter notebook. I noticed.
Correct.
Right.
Correct.
Yeah. Okay, go ahead.
But my main needs right now are a voice activity detector for those videos that work decently. Second, it's a criterion in which I can determine for how long a speaker is active. Because you can see here, there are moments they can be considered silence. But we know as humans that this is a whole thing. But for my program, because I'm using, for example, a quarter of a second segment, this may be silent. There is nothing here. So it can be misclassified. You start misclassifying that thing too many times, you're going to end up with an error. Because a quarter of a second times 4 is a second. And then you keep on going that way. If the video is very long, the error will keep accumulating and it's not nice. it's not that bad, maybe it's not that bad in the future, but I need that to know how many times I'm misclassified. And then when I do the segmentation, I need to know, and the classification, I need to know which one of the segments correspond to who. So in other words, correlate my analysis with the actual audio. Make sense what I'm saying?
I think so, yeah.
Okay, let me show you something here.
Can you give an example of a cross correlation that you're talking about? What do you-
Sure. Let me give you something first here. Hold on. Okay. You see this text file? This text file is generated at the end of everything and contains the speaker and the segment. For example, this is speaker number 4, segment 1. Speaker 1, segment 10. And it's this way because it's this way the software is doing it right now. It reads the directory, the folder at Windows. So it takes no sequentially numbers, but it takes it sequentially on Windows, whatever they use to put the things in order, okay? So each one of these things, the 10, 100, 101, is the segment number at 250 milliseconds from an audio track. So I need to relate each one of these things to the user that is talking in that particular moment. I'm explaining well, I mean, does it make sense? Please.
What do the numbers represent again, you said?
The first number on this data file is the speaker. The second number is the segment number. So this is segment number 1. In segment number 1 is speaker number 4. In segment number 10 is speaker number 1. In segment 100 is speaker number 1. 101 is speaker number 1. And then I take this actually thing here and I run it through another LabVIEW program that comes, no, this is not the one. Hold on.
Is that segment an actual time? Like
No,
a-
that segment is segment and speaker. Each segment is whatever, 250 milliseconds, 5 milliseconds, 500 milliseconds, no. I take those segments and I put a time base over here and then it tells me how many times those numbers repeat. For example, speaker number 1, 4 times, 4 seconds, speaker number 2, 5.5, speaker number 3, 8.5, and 7.5. But what I need to know is getting to each segment and correlate it with my audio.
In what way do you mean correlates with the audio? Because it seems like you've already done that. It says that segment number 100 is speaker number 1 or whatever.
Okay, you see here?
Uh-huh.
Each one of these is a 250 millisecond audio segment from the original
Okay.
audio.
Yeah.
Each one of them gets analyzed and the computer comes back with a number, for example, from this, okay? It comes
Yeah.
back and looks for segment number 1 here, and it tells you that in segment number 1 is speaker number 4,
Okay.
okay? For example, for segment number 10 is speaker number 1. I come here and this segment is speaker number 1. All these segments, one after the other, makes the whole audio track. So I need to go and say, okay, for 1, 4, for 10, but getting this thing in some side, in some kind of visual manner.
Okay.
Visual manner or some kind of thing that makes sense, because this segment has two. Let me play one of them. That's all you hear. So that's noise. For example, the computer is telling me that they get 100. There's somebody speaking there. That's speaker number 1. But that's all you get. Now, I'm trying to make those segments even smaller than that, and then I need to eventually recognize which one is which one. The only way to do that is to correlate those segments to the audio. to put it in such a way that, okay, these are the places which each one of the speakers are talking, according to the results.
So you just want to represent these segments in a visual manner, so it's easier for anyone to understand, rather
Exactly.
than.
So I can start checking how many misclassifications I have. You see?
And when you say visual manner, what are you thinking exactly?
Well, anything that can help me, for example, if I have this segment 102, and it's number one, I know, for example, that I should have the same speaker talking sequentially. Okay, so for example, I have,
Oh, I see. Yeah.
you see, for example, segment speaker 100, speaker 101, 102, and then I have a switch here to speaker 3, and then I have here noise, and then I have 2 and 2 and 2. I mean, I need to know if any of these things is a misclassification. And the only way that I can do that right now is just by going each one of these painful segments and play it and see if it makes sense. And if I keep on doing the segments even smaller, I don't want to be able to do that. Eventually, if I use a voice activity detector, which is something that I need right away, I may not need to do that because the segment will be long enough for me to understand and do it manually, which is fine.
So you want the segment to be long enough, you said, to have as much data as possible, but small enough. Why?
Because I don't have a voice activity detector right now. If the segments are too long, the speaker will start overlapping.
Okay, yeah.
Okay, so I have to make these segments very small, or as small as possible, so the possibilities of overlapping are very reduced. So in the exact moment that the speakers start overlapping, that's a segment that would be a misclassification, but it doesn't matter. It will be only one. But if they are too long, I will have more misclassification. The computer will get confused because there is a mix of things there, and it won't know what sense to make. So that's why it's important to reduce it. Now you have a voice activity detector. Your segment can be as long as the speaker is speaking, which is fantastic because the longer they are, the more information I have to do any calculations. The better the correlation will be. So that's number one. Number two, something to be able to get these numbers related to these segments here and to the original track. And number three, that probably is easier for everybody to follow, is I have a bunch of programs here that are from Speaker with Code, speaker recognition, speaker identification, and there is one here that is called the Top 23 Speaker Recognition Open Source Projects. I need somebody that get these things, these programs, and run it against my audio, so I can do a metric, a comparison. Okay? So if somebody wants to take this and run it, will help. So the other one, somebody wants to take a voice activity detector, will help. And somebody wants to take the correlation tip, not the correlation, the matching segments with the actual speakers, fine. I would say in order of importance, voice activity detector and speaker recognition metrics. Those two. Those are, about this, to run these things, it takes a long time to get everything prepared. I don't have that time, I just don't have it. So I need somebody that takes over this thing, run the metrics, run the comparisons, and let me know. Because this will be critical. I mean, comparing with whatever is outside. Let's see who does better under the same conditions.
Okay, gotcha.
Okay.
I mean, please add me, because this is, I mean, it is, there are so many things in here that I understand that sometimes it's difficult to try to communicate everything there. But if we want to get everything in a nutshell, will be to run these open source projects on the speaker identification, the speaker recognition. You see, this particular one, speaker idealization, this is what we're doing. If somebody can go and install a program and run it against with the videos that I show you, and tell me how good they are, that's fantastic. I need that right away. If somebody can come up with a voice activity detector for the videos, that's excellent. Because that helps a lot simplifying everything. Make sense?
Yeah.
Yeah, sort of. I think we're going to need to work through this.
Yeah.
And
But no.
we meet Wednesdays at 10:30, and we'll talk about this at that time. Okay?
Okay. Now, if you want to forget about everything that I'm doing on my stuff, and just getting any of these programs running, and running some of the videos and see how how well they do on the videos. That's all you need. That's all you needed. You want to get and work with some code, MATLAB code or Python code and some voice activity detector for those videos, for the video that I showed you on from Mario's. That's fine, and you can forget about everything else that I have told you. That's what I need right now.
Can you give us this data or send us this data somehow? How do we get a hold of it?
Okay, I can send you the links for these programs. These programs are written in Python and in GitHub. I'll send you the link for this website. I will send you the video, 2 videos for you to start. I will send you some code that I found on MATLAB. If you do a search, you're gonna find it immediately for voice activity detection. And I can send you the file that contains the results from the analysis, but you can forget about that for now. I mean, there is no really don't need to get into that right away. It's more important for me to have a metric, a comparison metric, and more important for me to have the voice activity detector. If I don't have a decent voice activity detector, I need to keep on going doing short segments, and then is when this segment correlation with the audio becomes more critical.
We got to get you into our Discord. We got a Discord chat session, and the material you could put on there, Tony, if you can. Okay. Probably better than emails.
Yeah, because the segments are kind of long, so I need to either use to Google Drive or something else. Yeah.
Yeah, we got to include you on our chat, and you could talk to us that way, and maybe send us some things, and then maybe we can access Google Drive too or something. Okay.
Okay. I can give you a full explanation of how all the software in the back works, but I need to prepare this in such a way that is easy to follow. But the only thing that I do is, I get a segment and gets that segment thinks that if it is a speaker number 1, this is the way it should sound. If it is a speaker number 2, here is the way it should sound. It calculates all the cross correlation between all the microphones and give you the best choice. So it's I had to prepare some kind of step-by-step presentation so you guys could see if you're interested on see how it works. I can run it here. It runs. Oops, no, stop. Oh, that segment does no longer exist. You can see how from the beginning to the end how the thing starts moving and moving there around and processes all the data and comes out with an answer. But I have to simplify this so it won't get confusing. Okay. Any other questions? Any questions? I know that it's kind of crazy. I know that.
Well, we're going to meet at I got an office. It's Dr. Santanam's office. It's ECE 327E, and I met last Wednesday, and we could meet there. Whoever wants to meet there, wear your masks and all this because it's COVID stuff still. But I don't know, maybe we could talk to you again at that time.
Okay, that's in the morning.
Yeah, in the morning.
About time? 10 o'clock?
10:30.
Huh?
10:30.
10:30. You do Zoom on the meetings or not?
What is that?
Zoom
Zoom.
is every Friday. Wednesday we meet in person.
Yeah, Wednesday we meet in person.
In person.
At 10.
Yeah. I work, so and I have some meetings on Wednesday morning, recurring meetings. So
Okay.
let me see what I can do. Okay.
Okay. I mean, we can meet you video wise, but
Well, the video wise would be easier because in that way I can finish with my meetings, which actually end at something like at 10 or something like that. I don't know what time they finish,
yeah,
and then I can switch here. All right.
right.
It will be easier. Okay. Let me know if that's possible. Okay.
We got some computers in EC327E. These guys could bring their laptops or whatever. But
Okay.
I mean, I like to meet them to get some face to face.
Yeah. No, that's much better.
Yeah, because we could talk about this online, and it's like, I mean, you're just showing us a lot of stuff. We need to get our hands on it.
Yeah.
So,
The sad thing about it is that I cannot right now transfer any of these programs to any other computer because I've been developing in this computer, and you know what happened. Everything is here and everything works, and I start moving something else, it may not work. So
yeah,
and actually the only thing that I want to do now is just finishing writing all the dissertation paperwork and all that kind of stuff, and then that's it.
well, the way I see it is that we want to get our hands on it,
Yeah.
and the only way we could really do it and try to help each other out is like meet in Dr.
Yeah.
Santanam's laboratory. We got about 5 computers there and a big screen TV, and these guys could bring their laptops if they want, but we got to talk about this and make sure we're all doing it correctly.
Yeah. Well, I can do that. For me, Fridays work much better because I have every other Friday off, and I can squeeze out of work Fridays as well, and I can prepare something that I can transport. Maybe I can be an executable or something like that we can just put in another computer and move it. I don't want to mess with it too much because every time I do change something, you know what happened. I don't want to crash this right now that I'm having some work results.
Yeah. But we got to get our hands on this stuff one way or another too.
You will. It will be open knowledge for everybody.
Okay.
And there is so much things that need to be worked here because, for example, if I'm not using a voice activity